Hi everyone, this is Dr. V.V. Kamesh, Professor of Mechanical Engineering, Aditya Engineering College, Sorampalam. In this lecture, I would like to discuss about Benson boiler. Okay. So the learning outcome of this lecture is, at the end of the lecture, the student will be able to explain the working principle of Benson boiler. The salient features of the Benson boiler we will discuss as a nutshell here. So the main important topics about Benson boiler, already we discussed in our earlier discussions, Cochrane boiler and Babcock and Wilcox boiler, right? So in contrast to other boilers, what it has, Benson boiler has some extra, right? So how it deviates? So first one is less cost. So why the less cost is there? Because of some other characteristic features, less cost compared to other boilers for the same capacity to be produced. And water tube boiler. Earlier we have classification of a 5 tube and water tube. So Benson boiler is water tube boiler and drumless. Okay. So in Cochrane boiler or Babcock and Wilcox, there is a steam drum. So water will be there, water will be converted to steam. So there is some storage of water, right? But here in the Benson boiler, we don't have any storage. Simply it is only pipes will be there, right? So water will enter the pipe and leave the pipe as a steam, right? So in between there are some passages. So drumless. So once the drum is not there, that associated cost will be minus. And it is high pressure boiler. We have the discussion earlier, low pressure, medium pressure, high pressure, right? So this is high pressure boiler. Up to 250 bar, you are able to attain. And this is forced circulation. The water will move in a forced circulation, right? So we will have some feed pump. So by means of the pump, water will be pushed inside with force. And the important characteristic, already we discussed just a few seconds back, once through boiler. Once through means at one end of the pipe, you enter the input water, and at the other end, the steam at high pressure will come out. So this is once through. So only by one passage, your water will be converted to steam at the end, right? And by these features, you are getting high thermal efficiency up to 90%. And the capacity is also very high. So 1,35,000 kg per hour. And because the Benson boiler is having only pipes and some surrounding, it is lightweight. Okay. And the various important parts of a Benson boiler are, look at the right side, there is economizer, there is radiant evaporator or evaporation process, and convection evaporation, and finally the steam will get outlet. Now we'll discuss in detail the structure of Benson boiler. This is the left side, you are able to see the line diagram, and the right side some with the colors, right? So Benson boiler is a vertical boiler. Shell will be vertical, right? But we can't say compared to the Cochrane boiler. Here, the structure is vertical, but there will not be any tube. There will not be any drum. Okay. Now you can see there is, for any boiler, you look at the bottom side, we will have some grate. So there we will place some fuel and fire will be initiated. Now look at top left side. Okay. So here I am having feed pump, right? So the feed pump with high pressure or with some pressure, it will push the water inside, right? So the first one is economizer. So whatever you are seeing here, the black color curves, all these curves are pipes only, right? All are pipes. Okay. Now, first one is economizer, right? So what is this economizer, convection evaporator, convection superheater, right? Or radiant superheater, whatever it might be. So all these are directly attached with your fire and gases. What are the hot gases produced, right? So now look at just only, don't look at the pipes now, just to look at only shell and fire, right? So once the fire is initiated, the hot gases will go upside, right? They will go upside. So what is there at the top? Exhaust gas, right? In the path between the fire generation point to the top outlet, in between, whatever the device you place, it will absorb the heat that is in hot gases, right? So there is some distance between the bottom to the top. In between, you place the devices. So the first device is, look at the top, economizer, right? So in between there are so many items. So by the time the hot gases will reach economizer, it will be, some of the heat will be absorbed by the bottommost parts. So some heat will be there. That heat, some of the heat will be taken by the economizer. So water will get heated, right? Water will get heated. Remember that point. So these economizer and the pipes will go directly to the downside, right? Directly to the downside. So you can look at the colorful diagram at the right side. So the feed pump, the water will go to the economizer, and directly the arrows are showing downside. So there you see the pipes are having some bends, rectangular bends, right? Left, top, again left, bottom, left, up, like this. Okay. So major area that is being covered with different pipes and bends. Okay. So here most of the hot gases, 100% heat will be absorbed by this these pipes. These are in direct contact with the hot gases. 100% direct contact. So maximum heat will be taken by the water here. So that's why it is called radiant evaporator. So maximum evaporation and conversion of the steam will be taken in this radiant evaporator. Okay. So after the radiant evaporator, I told you earlier, still the hot gases are going upside. So after much of the heat will be absorbed with the radiant superheater or radiant evaporator, still hot gases are going out with some lesser energy. That lesser energy also to be utilized. So what we will do? So we'll make the pipe to go up, and there is again, look at the orange color, right? That is convective evaporator. So again, the steam will take some of the hot gases heat, and the steam will get more heated. And next, it will go down, and the red color, still the steam will take much of the heat from the hot gases, right? So hot gases will give the heat to the water and the steam in different levels. First in the economizer level, right? Light. And next in the radiant evaporator to the high side, again to the convective evaporator at the medium side, and again superheater in somewhat more than average. Okay. So of these red color pipes, these are containing the steam at high pressure, because even in the radiant evaporator at the bottom side, much of the water will be converted to steam. The remaining addition of the heat will make your steam to be increasing the pressure. So pressure will increase, and look at the left side, there is a starting valve and superheated steam to the prime mover. So the high pressure steam that will be passed to the prime mover, which we are calling as turbine. Okay. Now we are having the different elements. Still one element is left. What is that? Air preheater. Look at the top side. Look at the top side. Just the exhaust gases are going out of the chimney, there is a small device that is called air preheater, hot air to the combustion chamber. Why this air is to be heated? So look at the topmost right side, there is a cold air in, right? And there is a blower. So water will get heated slightly, right? Why the air is to be heated? This hot air will go to combustion chamber at the bottom side, because suppose I need some heat. After burning up the fuel, automatically energy will be released. But already there is some heat, slight heat will be retained in the hot gases while they are going upside. Even for the economizer, it will take some heat only. The remaining heat will be taken by air preheater. Okay. So the hot gases heat will be given to water and air in different stages. First in the radiant evaporator, next in the superheater, next in the convective evaporator, next in the economizer, next to last thing, air preheater. So 1, 2, 3, 4, 5. So the hot gases heat will be given to the water and air in 5 different areas. So while the hot gases are going to out of the chimney, they will have very little bit of heat. Okay. So that's why the thermal efficiency is 90% nearly. Okay. Right. This is another diagram so that you can understand well. The arrows are showing the clear path, the water, how it is transforming in different areas like economizer, next radiant evaporator, next convective evaporator and superheater, and finally going to prime mover. So this boiler has the unique characteristic of an absence of the steam separating the drum. So without the drum, we are very happy because we need not worry about the scaling and other factors. So directly the water enter into one area and steam is going in other end. Okay. The entire process of the heating, steam generation, superheating is done in a single continuous tube. And the various elements are, I told you earlier, economizer. So in the economizer, the feed water by means of the feed pump is circulated through economizer tubes, and hot flue gases pass over the economizer tubes and the feed water is preheated. And this is the second stage, radiant evaporator. The feed water from the economizer flows into the radiant evaporator with the radiant parallel tube sections. The radiant evaporator receives heat from the burning fuel through the radiation process, and the majority of the water is converted into steam. And the remaining water that is in the convective evaporator, the remaining water, if any small water is left over, it is evaporated in the convection evaporator, absorbing the heat from the hot gases by convection. Convection means simply surface, okay, surface heat transfer. Thus, the saturated high pressure steam at a pressure of 210 kg per centimeter square is produced after convection evaporated. Now, the convection superheated, the last. The saturated steam is now passed to the convection superheater, where the saturated steam is superheated to 650 degrees centigrade. Remember, the steam is originally at starting 100 degrees centigrade, right? But it is increased up to 650 degrees centigrade. Now you can assume how much pressure it will build up. Okay. And the radiant evaporator, the convection evaporator, and the convection superheater are all arranged in the path of the flue gases. I told you earlier there are 5 stages, right? 4 stages to the water and 1 stage to air. Okay. And the steam outlet, the steam superheated steam is supplied to the steam turbine, to the steam outlet, and the capacity very high. So Benson boiler capacity is nearly 150 tons per hour, but we will maintain nearly 135 tons at a pressure of 210, but we are having the facility up to 250 bar, right? Or some with 225 bar also. And at the temperature maximum 650 degrees centigrade. So how the working of the Benson boiler, again, same thing is repeated in somewhat different terminology. It works on the pressure of the water, which is increased to the supercritical pressure, that is above the critical pressure of 225 bar. So when the pressure of the water is increased to the supercritical level, the latent heat of water becomes zero, and due to this, it directly changes into steam without any boiling. So this prevents the formation of the bubbles at the tube surface, right? So if the bubbles are formed, we are having the fear of some damage to the pipes. So without formation of the bubbles, we are happy with this. And in Benson boiler, the feed pump increases the pressure of the water to the supercritical pressure, and then it enters the economizer. So, the passage and outlet of the steam is already explained. So finally, the superheated steam is then used by the turbines or the engines to produce electricity. Now, the most important one, the advantages and limitations. So somebody may call limitations as a disadvantages also, but it is the difficult areas. So advantages are it is lightweight and it has no drum. For this reason, it is lighter than other boilers. And its starting time is less than other boilers. So nearly 10 to 15 minutes we are able to start. We are able to produce the steam. Okay. And it has up to 90% thermal efficiency already discussed. And the limitations. So even we are having so many advantages, still we are having some difficulties. Due to the supercritical types of the boilers, their controller needs to monitor every time for preventing explosion. You remember the pressure is nearly minimum 210 bar, very high pressure, right? So if there is any difficulty in the maintenance, there will be definitely a possibility of the explosion. And boiler control for the variable load is difficult. So based on the energy requirement, you may increase the boiler working capacity or you may decrease, but it is difficult in Benson boiler. And at this end of the lecture, the student have learned the characteristics and working principle of a Benson boiler and advantages and limitations. Thank you very much. If you like this video, please like, share, and subscribe. Thank you very much.